Okay, so sometimes we can't use the power rule, right? Just like with derivatives, sometimes we couldn't use the power rule. Sometimes there were questions where the power rule just didn't work, right? So we had things like product rule, quotient rule, chain rule, right? We had those rules there when the power rule wouldn't work. Well, same thing is true with antiderivatives. Sometimes the power rule just plain won't work, right? The first one it will, right? You can make it work with the first one. I can multiply out, expand it, right? Okay. This one, power rule won't work. It won't work. It won't work for this guy either. It won't work because this power right here is to the 1/2. That guy right there, this is a kind of a chain rule problem, right? These were, anytime we had this, it was a chain rule problem back when we were doing derivatives. So anytime we have stuff like that, we have to use what's called U-substitution. Okay, so that's what we're going to focus on. We're going to focus on this probably for the rest of the week. Thanks. So the rest of the week, it's gonna take a while to get U-substitution down. U-substitution. The thing about U-substitution, it's got a lot of steps. 8 steps. It's got a lot of steps, but the steps themselves are relatively easy. Each step is relatively easy. Okay, it's pretty simple. It's just got a lot of components. So it's not complex in that it's hard. It's complex in that there's a lot of moving pieces. Okay? The first thing is the hardest part. Finding out where to start. Finding out where to start. So, where do you start? Well, most of the time with U-substitution, when we're trying to find the antiderivative, so like if I was trying to find the antiderivative of each of these guys, I'm going to start with what's called the argument. The argument is the innermost part of a function, right? The function's got different parts. So let's start with the first guy here. Which part of that is the innermost part? Which part would you consider the innermost part of that, the argument? What part do you think is the argument, the innermost part? There you go. Yep. There you go. That is the argument. That's where we would start. That's probably the hardest part of all these steps. Okay. Let's look at the next one. The next one might be a little more difficult. Let's go to the third one. Skip the second one for right now and go to the third one. Where is the innermost part? This one could kind of be tricky. Where do you think the innermost part is? Where is the argument of this? There you go. Yeah, it's not going to be in parentheses this time. It's actually going to be in the root. You kind of get good at looking in certain places in parentheses sometimes. The first one was in parentheses. The third one we just did here was in the root, right? You kind of get good at looking at places. Okay, so let's look at another one. Where is the inner argument? Where's the innermost part of this guy? There you go. In the parentheses again, right? That's the inside, the most inside, right? So let's go back to this guy here. This guy doesn't have any parentheses. He doesn't have any roots. So where do you think the inside of this, the most inner part of this guy is going to be? This is the third spot where they're usually hiding. Not sine of x, close. The third place where they like to hide a lot is the power. Okay? So the innermost functions, if it's a complex function, means inside of a function, like these 4 guys are. They like to hide in 3 spots. Parentheses, powers, roots. Okay? Those are the spots they like to hide. That's where we start. That's always where we start when we use U-substitution. You see step 2? Find the argument. That's where we start. Okay. Okay, so here are the rules. Here are the steps that if you're in class you see on the board. They're also on here too. So step one. So when finding derivatives, we had the chain rule, right? We had the chain rule when we were finding derivatives. But in integration for antiderivatives, we don't have a chain rule. We don't have a power rule. We don't have a quotient rule. We don't have those rules that we had with derivatives. But we do have one big one, which is kind of a catch-all for antiderivatives, for integration, right? When I say antiderivatives, I'm talking about integration, right? Because antiderivatives is how we integrate. We use what's called U-substitution or U-sub, okay? We use U-sub anytime we cannot integrate, anytime we cannot find the antiderivative only with the power rule. So if we need something more hefty than the power rule, we use this step. We use this. So if you look at a question and you're like, I can't do that using the power rule, go right here. Okay, go right to there. Okay, so these are the steps we're going to use, and we'll do them step by step in a second here, but I wanted to post them so you can see them. Okay, so 1, 2, and 3. 1, 2, and 3. Or sorry, 2. 2A, B, and C. 2A, B, and C. So let's look at where's the argument again? So 2A. Where is the argument going to be? Where do you think the argument is for 2A? Where do you think it's hiding? Yeah. In the parentheses. Good. Yep. That's where it is right there. How about B? There you go. Yep. It's hiding in there, right? C. Parentheses again, right? 2 out of the 3 places they like to hide. Okay. Now what we're going to do for 3 is we're actually going to solve the problem here. We know what the argument is. We just did the argument. The argument is right here. All right, that's the argument there. Okay. This guy right here. So let me take away this. Let's look at it. I can't use the regular, or wait, I could use the power rule for this guy, right? I could use the power rule, right? What I would do is expand this guy. So I would have x squared minus 1, x squared minus 1, x squared minus 1, and 2x out there, right? So I would use FOIL here, and then use FOIL one more time, and then distribute, right? I could do that. You could do that. It'd take you a little bit of time, though. It would take you some time. Whereas U-substitution can do all of that, can do it without it, okay? So we're going to use this. Even though this is a power rule problem you could do, I'm not going to use the power rule, okay? So once we decide we're not going to use the power rule or we can't use the power rule, we go to step 2. Step 2 says find the argument. We just did that, right? I had it highlighted earlier. Let me highlight it again. We're going to identify that as U. So we're going to put U equals what we just highlighted, okay? So to the side here, I'm going to say U is x squared minus 1. That's going to be my U. The argument is always the U. Okay. Once I hit U, once I identify U, I find du. Du is easy. It's just the derivative of U. So what's the derivative of U going to be? 2x. Always needs a dx at the end, with a dx at the end. Okay, that's step 3. Step 4, solve for dx. Right now, it says du equals. I want it to say dx equals. So what do I need to do to say dx equals. What do I need to do here? There you go, right? So 1 over 2x. So I get dx equals 1 over 2x times du now. Step 4 done. Now we're going to sub in. Now we're substituting in. What am I substituting in? I'm substituting in u and du back into the original. Okay? So I'm going to rewrite the original. Instead of x squared minus 1, what's another way of saying x squared minus 1? What's another way of saying x squared minus 1? So not that way. You're right. You're right. But not that way, but in terms of what we did earlier in steps. U, right? Isn't x squared minus 1 the same thing as u? They're the same thing, right? So instead of this highlighted stuff, I'm going to replace it, substitute it with u. So it's u to the third power. Okay? Still have 2x. Right? Because this is the same thing. And then dx. What is dx equal to? So I'm going to replace dx with what it's equal to. 1 over 2x times du. Okay? That's step 5. Is there anything that will cancel out? Is there anything that will, can I simplify it in at all? Yep, this guy, oops, this guy cancels out with this guy, right? They're not there anymore. So now I have u to the third power du. Step 6 says move any constants, multiple constants. So if I had like a 3, if it was like a 3 in front or something, or a 1/2, oops, or a 1/2 or something, I would just move that to the front. That's what that means. But there is nothing here like that, so we don't have to worry about that. Step 7, do what you've done before. Find the antiderivative of u. Okay. Now I can use the power rule because this is a simplified version of it, isn't it? So the power rule says add 1 to the power, divide by that new power, plus c, because it doesn't have any bounds, right? Step 8, move everything back in. So instead of u, I'm going to move what u is. U is x squared minus 1. Done. Okay, that's u substitution. This is the antiderivative of the top. You found the antiderivative, but we just didn't use power rule like you did on your quiz, right? Because we couldn't, or we could, but we chose to use a different method. Okay, that's u substitution. Again, it's got a lot of parts to it, but the parts themselves aren't that bad. Okay, and doesn't matter what problem you're looking at, you're always going to have the same steps. Always going to start with the argument, then find the derivative of the argument, then solve for dx, then plug it back in, then move any constants to the multiple constants to the front, and then use the power rule, and then sub it back in. So you're always going to have the same steps. Okay, so let's look at another one. Let's look at B. Okay, first thing we do, well, straight up, we cannot use the power rule for this guy. We can't use the power rule for this guy because Even if I change this guy here, I can't expand that. It's 1/2, right? If it was squared, I could expand it. If it was to the third power, I could expand it. So, and I can't distribute the 3x squared. Can't do it, right? So, even if I wanted to, I couldn't use the power rule here. So I have to use U-substitution here. Okay. Find the argument. We did already. We said this part was the argument. All right, we said that's the argument. That's going to be U. Identify that as U. Okay. Find the derivative of U. Find the derivative of U. The derivative of U would be 3x squared. Dx. Okay, next step, solve. Solve for dx. Divide both sides by 3x squared. So this is dx. This is U. Okay. Sub in what you have for U and what you have for dx. Okay. So what I should have done first, which I did, was I need to change it to power. I should have rewritten it like this first. Okay. I'm going to sub into the one above it. So it's going to be antiderivative, or the integral, 3x squared. Instead of x to the third plus 2, I'm going to put u now to the 1/2. And then instead of dx, I'm going to put 1 over 3x squared du. If you do it correctly, some things should cancel out. Some things should cancel out. They always do. This guy and this guy. So when you cancel out, you might have a constant multiple, but you won't have x's anymore. You shouldn't have x's and u's combined. If you do it correctly, you'll only have u's, no x's. Okay? So now I have u to the 1/2 du. That's a lot easier to work with. I can use straight up power rule for that guy. I add 1 to the power. So if I add 1 to the power, it's going to be 3 over 2. Divide by 3 over 2. Well, when I divide by 3 over 2, you're really just multiplying by the reciprocal of 3 over 2 plus c. Move everything back in. So instead of u, you got x cubed plus 2 to the 3/2 plus c. Okay. Done. That's the antiderivative of this guy here. These guys are antiderivatives of each other. Okay. All right. So now let's try this one here. This one's going to be a little, not different, but it'll have a little twist to it that the others didn't. Again, could I use power rule for this one? Absolutely, you could. But you would have to expand it pretty big. That's just time we don't have to use. Okay. What else was I going to say? Another thing is, so big question is not the steps. Like, I don't get students asking steps so much. I get them asking, when do I use U-substitution? When do I know when to use U-substitution, and when can I just use a regular power rule like I did on the quiz? Here's what I tell them. Picture in your head, don't write this down, but picture in your head that this did not say this. Picture in your head, it said this. Would you use chain rule to do that problem there? If you do this, if you say yes, then to find the antiderivative, you're going to have to use U-substitution. If the answer is no, I can use regular power rule, then your answer is you can use power rule. Okay? So if I was finding derivative of this guy, would I need to use the chain rule? If the answer is yes, more than likely you're going to have to use U-substitution to find the antiderivative. Okay? All right, so this one, the inside part is here, so that's going to be my U. Du is just going to be 3 dx. Okay. Solve for dx. Dx equals 1/3 du. Done. This is my dx right here. All right. Step 5, substitute everything back in. So instead of 3x minus 2, I'm going to say u to the 4th power. Substitute instead of dx, 1/3 du. Now, what's the wrinkle in this question here? What's the wrinkle in this question that we haven't seen before in the last two? Does anyone see it? Yeah, Pete? The 1/3 is going to stay there, right? Yeah, the 1/3 is going to stay there. That's where we use step 6. Is it 1/3 x or 1/3 x squared? No. Are there any x's in there left? No. If the answer is no, we can go on. You've done everything fine. So what the 1/3 is, a 1/3, another way of writing this would be like this, right? 1/3 u to the 4th du, right? That is a multiply constant, multiplication constant, right? We know that we can move those to the front. We've done notes on that. We can move that 1/3 to the front. So whatever I get as an answer, I'm just going to multiply it by 1/3. So 1/3 here. So if you get stuff left over, it's okay as long as there's not other letters. You can only have one type of letter. And then for U-substitution, it's U. Okay? Oh. Okay. All right, so now find the antiderivative. Now I can use power rule. So we got 1/3 u to the 4th power means u to the 5th power divided by 5, right? Or times 1/5 plus c. All right, divided by 5 is the same thing as 1/5. I'm going to multiply it times the 1 Third I already have, so that makes 1/15. I'm going to put u back in plus c. Okay, done. There's a couple ways to check your answer. The first way to check your answer is when we did derivatives, what happened to the power when we did derivatives? When we were finding derivatives, what happened to the power every time? What would happen to the powers when we found derivatives? It'd go down in power, right, by 1. So when we're finding antiderivatives, it should go up in power by 1, right? Well, we started with a fourth, right? We ended with a fifth. So we did it right. So that's one way to check. Okay. Okay, so try the next one. Try B on your own. Okay, so when you get it, look up here. When you're done, look up here, see if you got the same answer. U is 5x plus 4. Anytime you have a power, change the or a radical or a root, change it to a power, just like we've always done. The derivative, found the derivative, divided by 5. I skipped that step here, but I just divided by 5 here. Plugged it back in, found the antiderivative. After you find the antiderivative, plug everything back in, put a plus c at the end, you're done. Okay, that's U-substitution. Now, we've only been focusing on polynomials, right? But there's other things. There's trig functions, there's natural logs, there's things like that. So we're going to be focused on all of those types of things, okay? But the basic steps are the same. The basic steps are going to be the same, okay? So we're going to continue with this tomorrow. I'm not going to assign any assignment yet because we're not there yet. But like I said, tomorrow and Friday we'll be continuing to work on these types of things, okay? Just so that you're used to seeing different types of situations, all right?